Okay, good morning to everybody. Praise be the Lord, now and forever. And we're gonna continue with this topic. This topic have been longer than it normally is, and it is because we review a little bit the ideas of or the methods to factorize expressions, quadratic expressions to be specific. Talking about those methods, we talk about the common factor, the guess and check, which has like three parts. If you remember, guess and check works like getting decomposing the first quadratic term and the independent term. But then we conclude that it's possible we finish into an exercise that is a perfect square trinomial. So this is one special case inside of the guess and check method. There is the other method we conclude, and it was the greatest, sorry, not the greatest common factor, the difference of two squares method. But right now we're gonna see how those expressions, how those methods, and how these can help us in order to conclude the solution of one quadratic equation. But let's talk about a quadratic equation. Any quadratic equation, it's an equation that contains a quadratic term. Yes or no question. Is the equation I'm doing right now a quadratic equation? Is that a quadratic equation? Nobody? Okay, do we have a quadratic term in here? Someone says in the chat, let me see. Someone says no. No with a question means that you're not sure. What makes a quadratic equation be a quadratic equation? Okay, we already talked about the quadratic expressions, yes? And the idea is similar. So the answer is no, because here we don't have any x to the second power expression. So how can this be a quadratic equation? Having this x to the second power, and now it's quadratic. Simple like that, okay? Simple like that. Every time you see expressions like x to the second power, you're talking about a quadratic expression. And do you remember what this x to the second power tell us? I mean, in a simple equation like x plus 3 equals 5, where x equals 2, for example, this x is to the power of 1, and it tells us one thing. It tells us that we're going to have one solution or no solution. So what do you think this second power tells us? If this one tells us that you're going to have one solution or no solution, this second power tells us that you can have probably two solutions, one solution, or non-solution. Yeah. Yeah, don't say it with that. Say it right now. Don't worry. I mean, don't say it. Two solutions. No, say two solutions, and that's it. Come on. If you're gonna mistake with honor. So if the situation, you're gonna have two solution, one solution, or no solution, or zero solution, right? So practically it's like that. Every time you see this exponent, the greatest exponent tells you that. So question, what do you think is going to be in x to the power of 3 minus 3 equals 5? In consequence, because this is related in general with polynomials. So what do you think? How many solutions this equation will have? Two solutions. It can have the two solution, but it can have, okay, it can have 3, 2, or no solution. So that's what we want, and be careful with this type of expressions. So excellent. So equation, the quadratic term tells you how many solutions you're gonna have. In this case, we're gonna look for two possible solutions, or sometimes it's just one, or there is not solution. We will see then the cases where we consider that there's no solution. So all quadratic equations can be written like next. Ax squared plus bx plus c equals to 0. And that's something we study at the moment to analyze quadratic functions. Those quadratic functions help us to identify a, b, and c. If you remember, I remember someone comment about For what's useful the C? For nothing in that case of the quadratic function, but for the quadratic equations, it will be useful. Of course, this is called a standard form of a quadratic equation, and it consists in just to leave the expression equals to 0. That's what you want to do every time that you have a quadratic equation in order to solve it. We're going to see why. So each of the solution of the quadratic equations are called roots of the equation. In other contexts, these are called like zeros of the equation because practically is related with that expression that you have to leave equal to 0 any exercise that has a quadratic equation. I mean, to solve that one, you have to pass this 7 to the other side, leaving 0 at this side in order to solve it. So this is like the introduction about what's a quadratic equation and the things we have to keep in mind to solve these ones. We're going to see how to solve it now. What's going to help us to solve this type of expression. And that's why I need to tell you or asking you if you know this property, the zero product property. Have you ever heard about it? Have you ever heard about the zero product property? Nobody? So if you don't know, the zero product property will help us to solve not just quadratic equation, will help us to solve in general polynomial equations. And I want to tell you something. Okay, normally I define the things by my way, no, not like by the ways the other math teachers always follow in the book. And for example, I like to call the zero product property like ZPP. So every time I said ZPP, thinking the zero product property, okay? That's on the page 19 of your book, and the zero product property says next. The ZPP tells you that if the product of two expressions is equal to 0, then one or another, or both of the expressions, sorry, are equal to 0 or is equal to 0. So what does it mean? Look, for example, suppose that you have 2 times, you don't know what, equal to 0. What is that value? What's the value that goes in here? It must be 0. I'm agree with you. And that's what the zero product property tells you. What about next expression? What about next expression? What happened if instead of work with numbers, we have x times y equals to 0? So which of those is 0? Here you conclude perfectly. The number you have to, that must be there is 0. Essentially, x and y, which are variables, works like this box. Someone says both or one. Okay, that's what CPP tells us, right? CPP tells us that x is 0 or y is 0 because both are unknowns. We're gonna suppose that both are zeros, okay? But not at the same time. The word or in math works like can include both and can exclude one of both. Works the two situations at the same time. It's like when you go to, I don't know, to McDonald's and you ask for some potatoes. What's the name of the potatoes? The normal one? So you have fries potatoes, right? And then you have the older one. The ones many of you like, I think. What's the one that many of you like? The mac potato. I don't know how is that, to be honest. I have times and years that not go to this restaurant. But that's my point. I mean, they tells you, can you choose one or the other one? But in math, the word or works like the two ways. You can choose one or the other one or both at the same time. So good, right? So this is what we want, and to be short. And in math, this idea of the word or, it's very important, okay? So how is that expression as algebra or using the algebra? We have that a times b, it's equals 0. It implies that a is 0 or b is 0 or both are 0. So here we have one example in order to show you then how this property will be useful to solve a quadratic equation. Here you have one expression that if you multiply it, then it's gonna be a quadratic expression, of course. But here you show this like a product, 2x times x minus 3 equals to 0. So as you can see there, you have two expressions. So we're gonna concentrate in those expressions. As you see here, you have 2x, and here you have x minus 3. So if the product of those is equal to 0, then it implies that or the first one or the second one, it's equal to 0. And why this is useful? Okay, I'm gonna show you then with one exercise. But the main idea of this is that you convert a quadratic equation into two simple linear equations you can solve just passing things to the other side. As you can see here, okay? So this is the zero product property, the CPP, like I'm gonna call it. Do you have any question about it? Do you have any question about it?
No.
No questions. Okay, let's see like the conclusion of this zero product property. This property will help you to convert the quadratic equation into two linear equations you can solve just passing to the other side, isolating the variable, right? Every time you see this property with a quadratic equation, consider two possible solutions, something we already talked, because probably it's just one or probably there's no solution. And something else, there are possible solutions because the equation can has two solutions, one solution, and the last one, no solution in real numbers. That one's underlined because it's very important because then we will see where they have solution, okay? I mean, they will have solution every time, just that not always in real numbers. Okay, here we have a simple like exercise. Given the next quadratic equation, what are the roots of the equation? So when I said the roots, I'm asking for the value of x that solve the equation. So here you have four options. I want that you try with one and you guess or see practically to like check which of these one works. I mean, replace the value of x, any of those. Okay, it means that if I replace x like -4 here, I have to replace x like -4 in here too. Then I'm gonna do it with 9, okay? With -9. I mean. So which of these four is the answer? I want that you try your own right now. Again, all that you have to do is choose any, choose A, B, or C, and then replace first that x here instead of that one, and then the other one, and conclude what are the solutions or what are the roots of this quadratic equation. Try it, please, and then tell me what's the answer, if it's letter A, B, or C. Which one? I'm gonna give you 1 minute. Somebody get the answer? Is that A, is that B, or is that C, or is that letter D? What's the answer? Okay, I'm gonna do it myself, but I need your help. I choose, I don't know, I don't know, but I'm gonna choose letter A, okay? I'm gonna choose letter A. Someone said something in the chat. Someone says that she think, someone says that think that this is the answer. No, no, I'm gonna check. In order to check, I'm gonna replace first x equals -4. And here we're gonna have -4 to the second power minus 5 times -4 minus 36, and it's supposed to give me 0. Here, I replace the value of x in here. Okay, the other answer, the other possible solution is x equals -9, and I'm gonna do the same. negative 9 to the second power minus 5 times negative 9 minus 36 equals to 0. So if you remember, we solved expressions like this one in our calculator. And that's why I'm going to solve these expressions in here. So I'm going to have negative 4 to the second power minus 5 times negative 4 plus 36. If it's give me equals to 0, means that negative 4 is one of the solutions. Okay, it gives me, oh, sorry, here's a mistake. Here's a mistake. Here's minus 36. And it gives me 0. Wow, is one of the solutions, right? It gives me 0. Yes, thank you, sir. I know that I repaired that. Okay, I think this one worked. Let's see what happened with negative 9. What happened with negative 9? And all that I have to do is change that negative 4 for a 9. Okay, you can do it in your calculator if you can. Here, because that one is a natural display or literal calculator, like I call it normally, that I can write everything like it is. And with this negative 9, it's supposed to give me 0 again. Look, it gives me 90. So what does it mean? It means that x equals 9, negative 9, I mean, is not a solution. So we can say that's not letter A. Not letter A. Not. And I think it's not B either, because here you work with negative 9 again, and it's not a solution. It means that this 4 is not a solution too, so here is not a solution. Let's try with C. C works with negative 9. I already checked it. Sorry, with negative 4, I think, and then with 9. I think C is the answer. So then you have 9 to the second power minus 5 times 9 minus 36. Tell me, please, if this gives you 0 or not. Do it with your calculator. So answer is C. You thought it's C, you were right. Okay, so here is the check. Of course, I'm not gonna check again with that. In this case, negative. Yes, it is right. It gives you 0. In this case, I'm gonna try with negative 9. I'm gonna try just with positive 9. And that's what you want to do at the moment to check an answer, an equation like that. It's supposed to be 0. There it is, 0. So it means this is the solution. Final answer of this exercise is C. Okay. So is there any question related with that? Do you have any question? No? Then we will see, because probably your question is how to get that negative 4 and how to get that 9. Then we're going to see how to get those ones. Right now, it's just to show you that they can have solution, and the solution of this one is not just one number, are two numbers because of that x to the second power that you have. Guys, it's time. It's exactly 9:20. We have to go to our break or dinner right now. I think some of you will sorry, breakfast. Some of you will breakfast right now. So have a nice day, and I hope you do a nice quiz. So bye bye, guys. See you in the next class. Bye bye.
Thank you, mister.
Welcome. Bye bye.